So hello everybody. I want to go over a couple more things in chapter 2, chapter 12. This is where we left off the other day, and we were talking about total risk being equal to non-diversifiable risk plus diversifiable risk. Okay, and then I said, well, every stock has a beta, and beta is an important thing. It tells you about the risk of a particular stock. So if you're going to buy stock, as I mentioned, you should always check the beta. The higher the beta, the higher the volatility in the stock. All right, so that beta comes into play when we, and this is a review. We've done this equation already. For those of you who haven't, I believe go back a couple chapters and look up the capital asset pricing model, CAPM for short, capital asset pricing model. And the equation for the required return on an asset is equal to the risk-free rate, which is treasuries plus the beta times RM, the market risk, which is the S&P 500, which you should know, minus the risk-free rate. So this is like a quick review of what recording I made the other day. All right, so here's the security market line. And basically, you can look at risk-adjusted discount rates as a table, if you'd like, and this is an arbitrary subjective number. They just call it a risk index. And here's the required return, and you'll notice for the two projects A and B, they basically say that the risk-free rate in this case for B would be 11 and for A would be 14. So that becomes important. And so you could just be subjective with that. And as you saw, because project A is riskier than B, its radar is greater than risk-adjusted discount rate is greater than 14%. Right? It's 14 and it's greater than project B's 11%. And basically, project B is preferable because its risk-adjusted net present value is greater than A. The one with the higher net present value is important. And here's a couple of, if you're using a financial calculator and a Microsoft Excel spreadsheet, you can go through these. All right, and here they are applying the risk-adjusted discount rate. Right here was project A with the initial investment of $42,000, and here are the cash flows, and here was project B with the initial flow of initial cash of $45,000, and here are the cash flows. And you notice here they're using R equal 14 for project A, and the risk-adjusted discount rate was 11 for project B. You'll notice this is an annuity. For those who have remember from 330. All right, so also the company can take different risk classes here, as you'll notice, again, arbitrarily, and assign risk-adjusted discount rates to them. And again, that's arbitrary to what a company would do. There's no science to that. All right, so the other thing now is what happens if projects have unequal lives? So far, we've been assuming that projects have all the same life. Maybe they're all 5 years, they're all 10 years. And if they're independent, the length of the project lives is not critical. But when unequal life projects are mutually exclusive and you got to take the one that's better than the other, you should look up the words mutually exclusive, right? One eliminates the other. So the differing lives must be considered because the projects do not provide service over comparable time periods. In other words, one is longer than the other, right? So we got to worry about that. All right. So here's a typical example of that. And here's a company that has two projects, and you notice that project X is only 3 years and project Y is 6 years, right? Here's the initial cash flows. And here's how we would do this in a financial calculator, right? To calculate the net present value. And you notice this has a higher net present value. All right, and here's the Microsoft Excel version giving you the net present value right there. If you have any questions about using net present value with a Microsoft Excel, please let me know. So if we ignore a difference in their lives, both are acceptable and have positive net present values. So if the projects were mutually exclusive, project Y would be preferred over X. And however, all right, it is important to recognize that at the end of its 3-year life, our project Y must be replaced or renewed. That's the problem, you see. So we use this approach called the annualized net present value approach. And we basically, there's 3 steps here. And this evaluates unequal life projects that converts the net present value of unequal lives mutually exclusive projects into an equivalent annual amount. All right, so there's 3 steps. Calculate the net present value of each project, J, over its life using the appropriate cost of capital. Convert the net present value into an annuity having life, and this is, find an annuity that has the same life and the same net present value as the project, and then select the project. The final step, of course, you take the project that has the highest annualized net present value. So we looked at these before, right? We did step 1 already. Here was the net present values that were calculated of X and Y, and they were discounted at 10%, right? They were discounted at 10%. Now we got to go through step 2, right? In this step, we want to convert the net present values from step 1 into annuities. Remember, annuities are constant cash flows. Go back to chapter 5 to review that if you haven't. So for project X, we are trying to find the answer to the question, what 3-year annuity equal to the life of the project has a present value of $11,277.24, its current net present value. Likewise, we do the same thing for Y, and once we have these values, we can simply determine which project X or Y delivers a higher annual cash flow on a present value basis. All right, so we take the 2 projects. Here was the net present value, and using a financial calculator, we calculate that the payment basically is negative for this, right? And negative for this, right? So here's the 2 payments. Negative means right, we're shelling out money, right? And that's just simply the way the calculator does it. In reality, the payments are, right? If you use the Microsoft Excel, the payments are positive here. All right, the calculator does it a little differently. All right, so here's the net present value, and here is the annualized net present value. So here's these payments of $45.34.74 and $43.65.59. So basically what that does is right, we take that payment and we put that in here as our annualized net present value. And reviewing the annualized net present values in step 2, we see that project X would be preferred over Y. And I'll go back and we'll look at that. Look at project X, right? You can see it's got a higher annualized net present value. Everyone see the difference there? All right. We're not going to worry too much about real options, right? So I'll kind of like gloss over this. And you could read this, but there's really no mathematics, and it's just the concept of real options is if you have a choice. Let's say you had a warehouse and you had a product you were making and you weren't making the product anymore. You have a real option to use that space to do other things. You could rent it out, right? You could do other things. And a real option is doing something and having an option, right? So if you bought a Uber car, or if you bought a limousine, let's say, you can use it to drive around in, but then you could use it as a Uber car too, right? That's a real option. So you go over these, real option, items, but there's no real mathematics behind it. All right, so capital rationing, all right, is just basically telling you that how much money do you have and how many projects can you do. You have a budget constraint here, right? How many projects you have and how many you could do. All right, so that's pretty much it for this chapter. If you have any questions, as always, just please email me, and I'll be making a video about the homework soon. I know you have some questions about the homeworks. Alrighty, talk to everybody later. Have a good day and a good week.